conservation of momentum. The second and third law of motion led to one of the most important and fundamental principles of physics called the law of conservation of linear momentum. So, what is the statement of this law of conservation of momentum? When no external force acts on a system of several interacting particles, the total linear momentum of the system is conserved. We can consider a system, and the system consists of some n number of particles are there, and they are colliding each other. They are moving and they are colliding each other, and this is an isolated system. So isolated system means the external force acting on the system is equal to 0, which means that there is no force, no external force exert on the system. So due to the collision of these particles, there is a mutual force between the pairs of particles in the system. So due to these mutual forces, there is a change in momentum, that is its momentum is mass into velocity. So the velocities of the particle may change. It may be increase or decrease, or its direction may change. The velocity, the direction of the velocities may change. But according to the third law, the forces acting on these particles are equal and opposite to each other. So because of this reason, the momentum changes cancels in pairs. So the total momentum remains unchanged. So this is known as the law of conservation of momentum. So once again, when no external force acts on a system of several interacting particles, the total linear momentum of the system is conserved. Now we can see one example of law of conservation of momentum, recoil of gun. Here we can see a gun firing a bullet. So this is a system. This is an isolated system. No force is exerting or acting on the system. That is, we are not pushing the gun. But inside the system, a particle, that is gunpowder, blasts and it pushes the bullet outside. So when the bullet is moving forward, when the bullet is firing from the gun recoils. The gun moves back. So the force exerted on the bullet by the gun, that is equal to F, and the force exerted on the gun by the bullet is minus F, because the gun recoils. So here this is an isolated system and no external forces are there, and there is an internal force, that is the gunpowder blast, and it exerts a force on the bullet that is inside the system. So the bullet is firing forward or moving forward, and due to that force the gun recoils back. So the force exerted on the bullet by the gun, that is F, and the force exerted on the gun by the bullet is minus F, that is according to the third law. Then these two forces act on a very short interval of time, that is a common interval of time. So the F delta t, that is the change in momentum according to the second law. So F delta t is the change in momentum of the bullet, and minus F delta t is the change in momentum of the gun according to the second law. Then since initially these two, that is the gun and the bullet, are at rest, but after firing they changes but equal and opposite to each other. They moves, okay, but equal and opposite to each other. So this F delta t is the change in momentum of the bullet. So we can note it as PB. F delta t, that is the change in momentum of the bullet, noted as PB. And minus F delta t is the change in momentum of the gun. So we can note it as, that is the minus PG. This is the recoil momentum. PG is the recoil momentum of the gun. So according to the third law, these two forces are equal and opposite to each other. So the momentum also equal and opposite to each other. So we can write PB equal to minus PG. Therefore, PB plus PG equal to 0. So this represents that the total momentum of the system, that is bullet and the gun, is conserved. The total momentum of the system bullet and the gun is equal to 0. So we can say that the total momentum of the system is conserved. Okay. Total momentum of the system is conserved. So this is the law of conservation of momentum. Law of conservation of momentum. The total momentum of the system is conserved. So this is an isolated system, and this system consists of gun plus bullet. Okay. Dear children, we studied about the statement of law of conservation of momentum, and we proved it with an example of bullet and gun. Now we are going to study about the application of law of conservation of momentum, collision of two bodies. So in an isolated system, we consider two bodies noted as A and B. Now, before collision, they have the momentum, they have the initial momentum, that is PA and PB. So this momenta is before collision. Okay, before collision, the momenta of A is PA and momenta of B is PB. Then they collide each other and get apart. So their momenta will change and it becomes PA dash and PB dash. So this is after collision. So after collision, the momentum of bodies will change. That is PA dash and PB dash. Then according to the second law, so we can note here, this is the initial momentum. Okay, this is the initial momentum and this is the final momentum. And according to the second law, the force exerted on A by B in a very short interval of time changes the momentum of the body A. Okay, according to second law, force exerted on A, okay, we can write here, force exerted on A by B in a very short interval of time changes the momentum of body A. That is equal to, that is the final momentum PA dash and initial momentum PA. So change in momentum PA dash minus PA. So this is according to the second law, okay, Newton's second law of motion. Similarly, the force exerted on B, okay, the force exerted on B by A in a very short interval of time delta t changes the momentum of the B. So we can write PB dash minus PB. So this is the change in momentum of the body, that is force exerted on A by B in a very short interval of time delta t changes the momentum of A. Similarly, force exerted on B by A in a very short interval of time delta t changes the momentum of B, that is PB dash minus PB. Then according to the third law, these two forces are equal and opposite, that is force exerted on A by B is equal and opposite to force exerted on B by A. So we can write FAB equal to minus FBA. So we can cancel this delta T. So this is according to Newton's third law of motion. FAB equal to minus FBA. So what is FAB? That is equal to PA dash minus PA. And what is FBA? That is here one minus sign, minus of PB dash minus PB. Then we can rearrange it. So PA dash, then minus PB dash. We can take it on the right hand side. So plus PB dash equal to minus into minus plus. And this minus PA, take it on the next side. So PA, then minus into minus plus, then PB. Okay. So what is this PA dash plus PB dash? That is PA dash and PB dash are the final momentum of the body. So we can write here final momentum is equal to, okay, final momentum is equal to, what is PA and PB? That is the initial momentum. So final momentum is equal to initial momentum. So what does this represents? That is momentum of the system is conserved. Okay, momentum of the isolated system. So here the bodies are inside the isolated system. External force is 0. So momentum of the isolated system is conserved because final momentum is equal to the initial momentum. So this example shows that total final momentum of the isolated system equals the initial momentum.